Okay, so we've done our first goal, we've done our second goal. Now we need to just translate these concentrations into the moles of each, and then finally into the grams of each. So this is this next part is review from way back when we did molar mass and concentration calculations. So I think that most of the bulk of the work is behind us at this point, but let's move on to this third part. And so what do we do if we have, let's take our 0.180 molar concentration of HA first, and figure out, well, how do I find the moles of that? Well, I know that the molarity is really just moles per liter. So if I take 0.180 moles per liter and multiply it by the liters that I have of my solution, then I should be able to get moles. And I'm told that I need a total volume in my solution of 125 milliliters. That's the same as 0.125 liters. So my volumes always have to be in liters in order to cross out the liters in molarity. Okay? So if I do that, I should get 0.0225 moles. And let's remind ourselves what this is. This is actually acetic acid. Okay? Do the same thing for the A minus. We get 0.320 molar A minus. And then we're going to also multiply that because they're in the same solution together. The total volume is again 0.125 liters. Okay. And so that gives us 0.0400 moles of our sodium acetate, CH3COONA. So in sodium acetate, our sodium is taking the spot of the proton, and it comes off all the time of every single molecule when you dissolve it in water because it's an ionic bond. And so really, this is the same as my CH3COO minus. Okay. All right. And so I can say that the CH3COO minus, so 0.0400 moles of CH3COO minus that means I need 0.0400 moles of CH3COONA, because that's basically just my delivery system for the CH3COO minus. Okay. All right, so now the next step and the last step is to translate these into grams, because if you're doing this in a lab, you're going to need to weigh them. That's our only way of finding out how many moles we're adding, is to weigh it. So if we have to do molar mass calculations, so let's do the CH3COOH first. If we calculate the molecular weight of the acetic acid, this is equal to 60.06 grams per mole. Okay, and we know that we need 0.0225 moles of the acetic acid. So we're going to multiply that by our molar mass, or molecular weight, and we get 1.35 grams of CH3COOH. Now we know we can bring our bottle of acetic acid and go weigh it out, okay? Or use the density to find out how much volume it is if it's a liquid. So let's then do the same thing for our 0.0400 moles of CH3COONA, and the molar mass for that, or the molecular weight for that, is 82.04 grams per mole. If we do that calculation, we should get 3.28 grams of CH3COONA. So we have more grams of the sodium acetate, and that's for two reasons. First of all, the sodium acetate just simply weighs more than the acetic acid because it has that heavy sodium atom on it. And secondly, because we need more of that base in order to raise the pH above the pKa.